So it's now my pleasure to introduce the first guest. His name is Patrik Dahlqvist. He is with us via Zoom, and he is CEO of Insplorion. Insplorion is a company that offers battery and air quality sensors and NPS-based research equipment. Let's find out more about what they do.
Thanks for the introduction. Hopefully we can be able to share screen here too. But I do get a message that host has disabled participation in screen sharing. Could someone help me with that? There we go. Thanks a lot. So, thanks for the introduction. I am Patrik Dahlqvist, CEO of Insplorion, where we are developing sensors for cleaner air, accelerate transition to fossil-free energy, and better research for life science and clean tech. It's a pretty good timing to be a new sensor technology company. Looking at the mega trends in the world, PVC, for instance, are picking out 5 of them. 2 that are not as directly relevant for us when it comes to a growing population as well as a shifting global power. But 3 of the mega trends are where we fit in and where we try to help and where we, which enables us. Climate change is something that is on everybody's lips, except when COVID isn't. And then we have a continuous accelerating urbanization taking place. Supporting us and providing the infrastructure for sensors is the rise of technology with Internet of Things. It would not have been at all as easy to come with a cost-effective, efficient sensor technology just 10 years ago. So that is good to keep in mind when looking into why sensors are becoming an interesting topic nowadays. When it comes to problems that we want to help in solve, we are a small startup company, growing fast, but still a fairly small player. But we have high ambitions. We want to help out and support with the big problems here in the world. And 2 of them are related to fossil fuel and usage of fossil fuels. Carbon dioxide and the problems that they give us with an increased global temperature, which can be seen especially in the Arctics, where we have less ice mass. But also it has been easy to track extreme weather, and extreme weather is 5 more times more common now than since the 70s. But what might not be as well known is how fossil fuels also create nitrogen dioxide, which is together with particles is very unhealthy for us. On a global scale, bad air quality kills about almost 9 million, and half of that are related to what happens when burning fossil fuels, and especially in cities. Almost or a little bit more than 4 million people die earlier than what they would if it due to bad air quality. This number, I think, is worth to have a second look at. Looking at our current crisis with the COVID, we are now at about 1 million people who have died earlier due to COVID. But on a yearly basis, there are 4 million just because of air quality is bad in especially the urban areas. But it's not only that it's unhealthy, it bad unhealth also is creating huge costs, especially when it comes to that people can't go to work due to respiratory failures, asthma, and these kind of effects. On a yearly basis, the cost is in the range of 1,200 billions just in Europe. And this is starting to be seen and looked into more and more. And that's why we start to see stronger and stronger regulations about to get better air quality. But to get better air quality and to help in solve other factors, such as improving batteries and improving the new technologies, such as technologies used to adopt to hydrogen for hydrogen cars and so forth. All these systems need to be optimized. And to be able to optimize, you will need to measure. And to measure, you basically need sensors. And there is where we come in as a new technology company. With our air quality sensors, we help to optimize where to do infrastructure developments in cities, but also to help private persons where to do their jogging this morning instead of this park instead of that park. When it comes to batteries, it's a new technology that needs to be optimized, and to do that, we basically provide sensors to support with that. And hydrogen, which is coming as an alternative, especially for long range and long cycle storage. There is an increasing need for safety, and to be able to have safety, you need to measure that you don't basically have leaks. And that's also an area where our technology fits in very well. It all might look a little bit spread out with both working with air quality, battery sensor, and hydrogen sensors. And then we also have for almost 10 years been selling this technology as a research instrument. But from the inside, from our side, it actually looks exactly the same. They are all based on the same sensor technology, nanoplasmonic sensing, that we are developing within Insplorion. It's a technology that has 3 patent families to protect it, and it serves as the basis for all applications. Just a few words about what the technology is about. This is the only technology slide, so bear with me. But basically what we have is a platform technology where we are using nanoparticles on a surface or a fiber. These nanoparticles basically work as antennas that enhance an optical signal. So we have a signal enhancer thanks to the nanoparticles. Due to these increase in signal, we can work with low-cost components and still have a very high sensitivity. And this is the platform that we have with all our applications, where our nanoparticles enables us to work with cost-effective components and still have a very high sensitivity. In that way, our platform can become both small, robust, yet sensitive, and we can go in and work with applications where there is a high demand for to detect small volumes, but where we also can work with many sensors at the same place. What we then do is to also coat our sensors and have different materials on top of them, and that is how we get selectivity for different applications. So this part is the same for all our applications, but for air quality and for hydrogen and for battery, the coatings are different. It is, as I mentioned, patented, where the mother patent has been approved in all major markets, and where our gas sensor as well as battery sensor patent are being approved in most, but it's in most major markets. A few more words about air quality. It's air quality is something that you can measure today. For instance, you can look at air quality index on your cell phone, but that is based on high cost research instruments or measurement instruments that are placed a few in each city and often sit in rooftops. And that gives a good average of what problem you have with air quality in the city that day. But to be able to optimize and, for instance, start to make infrastructure, good infrastructure decisions. Should I exchange this part of the bus line for electric buses instead of diesel, and do the correct one, the correct decision? You need to have much better resolution and know which street has the problems, and not only on the city level, but actually on a street level. So in order to do that type of optimization, you need to have many more sensors spread around that are also giving information in a timely way. So to be able to measure both these low concentration as well as in many more places in real time, there is a need for new technology. Current sensors do not do that. And that is the reason why we started to develop and focus on nitrogen dioxide with our air quality sensor. We are now in a very early commercial phase with our air quality sensor, where we have started together with collaborations to work with Mölndalsstad. And where we have a first sales. We have an ongoing collaboration with Göteborgsstad in a project called Internet of Things, Air and Water. And we have a collaboration with a small startup company or a small company called Leading Light, where we have implemented our sensors into their smart city lighting to get the first reference customers. What we have also started to see when, even though we started with smart cities, the need for measuring nitrogen dioxide are also increasing inside building and especially in garages where you have problems with nitrogen dioxide due to combustion engines. You also have these type of problems in closed compartments where there are any type of diesel engines or any type of fossil fuel engine, such as mining, where we start to see that there is also this need for many sensors to measure locally and fast. The way that we work with getting to the market is basically working locally first with references customers in the Nordic countries, and before going to Europe and Asia. It is, as can be expected, a huge market in the numbers of billions when it comes to measurements for air quality, where we of course only have the possibility to grab a small but still significant chunk. A few words about our battery sensor. As you all know, we start to see the transition to a battery-based energy. Electric vehicles are mostly known, but energy storage based on batteries is also picking up speed. But to make this transition to happen faster, batteries need to be more efficient, especially having a better ratio with cost and to energy density. And one way to do this is to make them operate a lot more efficient. This whole project started out with us taking our technology, being a university spin-off from Chalmers in Gothenburg. We, of course, walked over the water and talked to Volvo cars. And they told us about this frustration that they had, that they become more and more dependent on batteries, but still were not able to optimize the batteries. And they basically told us about this problem, that they today need to use pretty large safety margins just not to harm the batteries, and basically set limitations in their control system, their battery management system. We started to look into this and realized that, yeah, it is a big problem. And this frustration is not only with cars, it comes with every battery. We can, for instance, ourselves see it when our cell phone goes from 30% down to 5% for no reason. That is due to that the current sensor technology is not efficient when it comes to measure batteries. And they basically told us that any type of information that can help us run the batteries more efficient is what we need. So we started our battery sensor project, where we basically go inside the battery and are able to bring in to the battery steering information about chemical changes, and then it becomes possible to optimize the batteries in a much more efficient way than previously possible. This is a project, since its batteries are complex and the value chain are complex for batteries, we are working mostly with larger development projects where we have been successful in getting European funding in mainly two major projects. But it's maybe not only the funding that is nice, it's also give the credibility for the technology, but it's mainly the network that we get for the battery industries, where, for instance, the 3Believe project, where we are developing the next automotive battery. It's more than 15 partners involved. Fiat and Volvo are the automotive parts, but the whole battery value chains are involved, so that we basically get access to and get involved with these type of players. The market, as expected, are huge, but it's interesting to see that when it comes only to sensor and steering type of technology for automotive battery sensors, that is expected to, in a few years, be in the range of close to $5 billion. So the need to optimize and that sensors plays a big part of that. It's something that the industry is picking up more and more. Hydrogen is a project that we fairly recently started to work with within Insplorion, but it has been running quite for some time with our collaborative group at our founding group at Chalmers University. The reason and what has been really nice with this project is that our founding group from the very start to look at the needs for hydrogen, where there is a need for better safety, especially when starting to look into hydrogen fuel stations, but also in infrastructure. And when it comes to safety, one of the most important features is to have a sensor that will respond quickly. And our founding group were able to continuously evolve the coating of our used on our technology for hydrogen, so that they could show that the technology now is the fastest hydrogen sensor around. With that, we now have the possibility to implement in our platform that we have evolved with our air quality sensor. And thanks to that, we have been able to move very fast with this project. We are now developing together with PowerCell as well as Chalmers. with the aim, especially for safety, but also for process control. It has also been clear that the rest of the industry is picking up interest. For instance, we are finalists in the Shell Energy Challenge with our hydrogen project. A few words on the sales that we are doing now. Except for air quality, the other projects are still in development phase, but we have continuously sold our instrument as a research instrument. We have 3 different products when working with the technology looking at liquid applications. So this is for life science, in air and high temperature, as well as in combination with our other instruments. What is nice with selling it as a technology, especially for academia as a research instrument, is that the technology becomes much more and faster established what it can do. There are already more than 90 scientific publications using our technology. So what it can do and how it works is well established now. It's also a way to get our technology out there globally. When selling to academia, one of the benefits is that it's basically where you have strong universities. So basically where you have strong universities, there are research customers using our instruments. And it's also nice in this way that we as a company do not need to focus too much of our efforts on research. We can stay on the development and prototyping and matching our technology with where it makes most need on the market, so that we can make this fit. Where is there an unmet need on the market that our technology can fit with? But for instance, both with battery sensor, especially with both the battery sensor as well as the hydrogen sensor, a lot of the technological verification and development has been done in collaboration with academia. And we can focus on market development and prototyping and patent, and matching it with the market needs. And then we work in a collaborative way with both small and large actors, where we initially take a larger part of the value chain before when we see that we step back because there are other people that are good at mass production. And that is basically how we work with all our applications. That we, for instance, with air quality, we work with a small actor such as leading light just to get market traction, and then we can, for higher volume, work with other actors where the manufacturing can be made with a company such as Littelfuse, where we have an ongoing collaboration. Same with battery and hydrogen. We work with PowerCell as well as Antepowers, which are fairly small players, to develop and get market traction of our technology and learn the market. But then it's other type of larger global players that we see get interested in the technology, and where we can take a step back and it becomes more of a license type of sales for the large volumes. About the company, we are now 12 employees. We have recently strengthened our board with Jonas Inger, who comes in with a commercial focus, but still a heart for technology. So I think that is a very strong mix supporting us. We have in the team, we have a good mix with market and sales and business development people, but still have our core knowledge with technology development and product development. And of course, we work strongly with our academic partners at both Chalmers and Uppsala, for instance. We have been listed at the Spotlight stock market for a little bit more than 5 years. We have a value of about 25 million euros. Definitely more than 2,000 shareholders. I see a little bit different figures on that, and have currently a strong funding since a little bit more than a year ago. So to summarize, we have a innovative sensor platform that are active and where we sell in important areas where we try to help on a global scale for air quality, to make better decisions how to solve air quality problems, for batteries, to get more out of batteries that currently can't be used by measuring inside the cell, and for hydrogen, to solve the problems with safety around hydrogen handling, both inside transportation methods as well as infrastructure. And we have a technology that is verified, and it's becoming more and more verified as we sell it as research instruments. It's patented, and it's a platform that is small, robust, sensitive, yet scalable. And with these areas, research instruments are on the market, has had a continuous sales. Air quality is very early sales. Hydrogen and battery is moving on into demonstrations in real life. That's my presentation. I hope I kept my time in a good manner, and hope to have some good questions. Thank you very much.
Thank you very much, Patrik Dahlqvist from Insplorion. I have one question here. We took questions from all you attendees prior to this event, so I have them here in my script. And here's one for you, Patrik. Which battery sizes / applications is Insplorion ideal for?
We started out with the automotive industry, so that's where we have much data. So when it comes to which battery chemistries that we have tried at least 4. We are not dependent for specific chemistries, but there are so far, except for sodium ion, are different varieties of lithium ion. LFP and NFC are the 2 chemistries that we have mostly worked with. And we have both worked with coin cells, patch cells, and pouch cells. Coin and patch are mainly used in research, while the pouch cell is the more dominant cell type, especially for which is growing more for automotive. But we see automotive as the long-term goal, and there are quite a few battery applications getting there. For instance, working with industrial power tools and also supercars and utility vehicles.
Well, thank you very much, Patrik Dahlqvist from Insplorion, and best of luck.
Thank you.